Hello, welcome to Mathsoc seminar. I guess we'll get started in about 5 minutes. And I'm going to just minimize this. Alright, so I think we'll get started in about 5 minutes. Alright. Can I get someone to check the live stream? Make sure it's no big issues. Sure, yeah. Alright. Bless you. Yeah, we're live. Cool. Alright, we want to get started? Let's go.
Okay, hello everyone. I'm Jasmine, and Wesley and I are going to be taking you through the Maple1B workshop. So we'll just get straight into it. So throughout this workshop, we're going to go through functions of two or more variables, further calculus, further linear algebra, 3D geometry, and programming in Maple. So for functions of two or more variables. So let's just get into a worksheet in Maple first. Okay, great. Alright, so just some revision on the difference between expressions and functions. They are treated differently in Maple. So an expression assigns a value to a variable. So use the colon and then the equal sign to define an expression. Whereas a function takes an input value and produces an output value. So you use the arrow symbol to define a function. You will need to use the subs command to evaluate the expression. So entering E42 below won't work for the expressions, it'll only work for functions. So just for an example, if we're doing the expression E equals x to the power of 2 multiplied by y minus x. Yep, so that's an expression here, and then we can differentiate it by using the diff command, diff of E with respect to x. And then we can use the subs command to substitute in x equals 4 and y equals 2 into E. Nice. Okay. And then to define the function f, we do f colon equals xy, so they're the variables in f, and then the arrow x squared times y minus x. So that's the same, so that's just like shows it's a function down here. And then we can substitute 4 and 2 in, which equals the same, 28. So we know that the 4 is going to be x because over here we've said, like, we've just defined the first value is going to be x and the second value is going to be y. moving on to partial differentiation of expressions. So we can find the partial derivative using the diff command. So we list the expression and then the variables you are differentiating with respect to. So to evaluate the derivative at a specific point, you can use the subs command. And then for higher order derivatives, you can either list more variables or use the $ to represent repetition. Okay, so that's differentiate x squared times y minus x with respect to x. Nice, and then we can substitute x equals 1 and y equals 2. And then we can just use the percentage symbol to mean the equation just above. So yeah, that's 3, which is correct. And then if we want to do some higher order derivatives, we write diff x to the power of 4 times y squared with respect to x, x, x. So x 3 times and y twice. So we can just list them here. And that will give us the answer. But if we want to do it a bit faster, also if we might have to differentiate it like to x like 7 times, you might not want to write x, 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 x. You'll lose count. So this is just a handy way to do it a bit faster and you won't have to count anything. Nice, so it's both the same thing. Alright. So that was it of expressions, so now we're going to do of functions. So we can find partial derivatives of functions using D. So make sure you've defined your functions first, and then refer to variables by the order they appear in the function definition. So that's like in brackets x, y, with the first value being 1 and the second being 2, etc. So for example, d of 1 of f differentiates the function with respect to x, and d of 2 of f differentiates with respect to y. So if we define this function first, so f x, y, stepping arrow to x to the power of 4 times y squared. Yep, so that's defined, and then we can differentiate it with respect to x first. So that's why it's d square brackets 1, then normal brackets of f. So that's differentiating with respect to x, and now y, d square brackets 2, because y is the second one, and then of f. So, nice. So higher derivatives of functions. So the command D can also be used to find higher derivatives of functions. So we list more variables inside the square brackets or use the $. So to evaluate the derivatives at a specific point, enter the point in round brackets after the expression. So that's just to substitute. Scroll down the maple. How do I scroll down them? Like it's. I can just start a new
It's alright, it's alright. We'll just double check this because it's going to get in the way. Yeah, let's go here. Just for a quick fix. Alright. There we are.
Alright, nice. Okay. So D 1, 1, 1. So that's differentiating with respect to x 3 times, and then 2, 2. Differentiating with respect to y twice. Closing the square brackets and then normal brackets f. Nice. And then another way we can do that is just by using the $. So 1, because 1 represents x, and then differentiating it with respect to x 3 times, and then same for y. Nice. And now if we want to substitute, if we wanted to substitute a point into above, yeah. Okay, I'll just write it again. d1, 1, 2, 2, f, and then we just substitute x equals 4 and y equals 2. Nice. Okay. So to find the maxima and minima of expressions, we use the maximize and minimize commands. So we need to make sure we spell it with a z. Otherwise, if we use an s, it won't work. So we can also find it the maxima and the minima between two different endpoints just by typing 2 dots between the endpoints. Okay, so if we want to find the minima of sine x plus cos 2y between negative pi for x and pi, and then between negative pi and pi for y as well. So that's just negative 2. And then maximize to find the maxima. So spelling it with an Z. And it also will tell you, like, as you go, you can like see it says maximize. So hopefully you'll see that if you forget. So x times e to the power of negative y squared. That should just be infinity. Nice. Alright. Plotting. So to plot functions with 2 variables, we can use the plot 3D command. So we enter the expression and ranges for variables, and then you can click and hold on the graph and move the cursor around to change the orientation of the graph, allowing you to see it from many perspectives. So you can enter a set of expressions to plot multiple graphs on the same axes. So just using the plot 3D command first for the graph of negative x squared times cos x plus y between x equals negative 3 dot dot 3 and same for y. Nice. Okay, so here just comes up with the graph. And we can just hold our mouse on it, just click down, and then you can just move it around to see. Nice. Okay, and then if we want to plot 2 different graphs, we use the same command, but then we have to put list the graphs inside square brackets. So if we want to find x cubed plus y plus 1, and then also sine x plus y plus 13 times x times y, square brackets, x is between negative 2 and 4, and y is between 1 and 5. Nice. Okay, so you see there's 2 different graphs in these axes, and you just hold it, press down and move it to go around. Okay. So the next part is further calculus. So when integrating, it is often useful to simplify expressions into partial fraction form. So we can use the convert command with the parfrac option, and you'll also need to list the variables you're simplifying with respect to, for example, x. So let's just make a new, let's start again here. Okay, so we can use the convert command with the parfrac option to find the partial fraction and just to change forms. So convert, and then the expression you want to simplify. So 1 on x squared minus 4, and then we want it in parfrac form, partial fraction form, and then with respect to x. Nice. So that's just, yeah, in partial fraction form. And then if we want to integrate it, we just use the int command. And then, yeah. with respect to x. Nice. Okay, now for solving differential equations. So to solve differential equations in Maple, we use the dsolve command. So we need to write the subject of the function as a function of the independent variable. So in this case, we write y of x instead of y, or else it won't work. So we write the equation followed by y of x, since y is a function we're trying to find. So it's just a little bit different, like how you write it kind of thing. So if we want to write the difference, ODE 1 is an expression of derivative of y of x with respect to x. So that's just this bit right here. And then plus normal y of x equals cos of x plus x. That's it. There we go. Okay, and then to solve it, we just use the dsolve command. ODE 1 with respect to y of x. Very nice. Then it just gives you the solved version. Yeah. Okay, and then to find higher order differential equations, it works the same, but you just have to like list what you want to differentiate after. So like how many orders of differentiation you want to do. So for this example here, we'd say ODE 2 is an expression of the derivative of y of x twice, so we write x twice. You can also use the $sign notation here as well. It works the same. 3 times the derivative of y of x with respect to x just one time, and then plus 2 times y of x equals 3 times x squared. Nice. Okay, and then just use the dsolve command, ODE 2 with respect to y of x. Nice. Okay, and I'll just show you above that we can use the same. Yeah, it works the same if we just like do the $sign notation, if you want to use it there. Alright, so if we want to set initial conditions, we just enter the conditions as a set of equations inside curly brackets. So if we want to use the initial conditions of y of 0 equals 0, we can do first define the differential equation. So that's derivative of y of x with respect to x once plus y of x equals cos x plus x. And then use the dsolve command, and then you'll need to put it in curly brackets with oh sorry, I should call this ODE3 with the expression above. So that's ODE 3, and then also just write the conditions as an equation. So y of 0 equals 0, end curly brackets, and then comma y of x. So that's what it's to respect to. It's like above. What have I done? Okay, I didn't do the curly brackets at the start. There we go. Alright. So sometimes the initial condition will also have a derivative in it. So this one's like the derivative of y of 0 equals 1. So you'll need to write the condition. If it's the example y of 0, it's written as capital D of y of 0. So that's different from, it's like D in brackets y and then in brackets 0, it's different to D and then all in brackets y of 0. So just make sure you use the right way, otherwise it won't work. So for the fourth one, just define it again. X plus 2 times y x. Yep. And then desolve, open brackets, curly brackets, ODE4, and then we just list the two conditions. So that's, the first one's just y of 0 equals 0, and the second one's the derivative, so d in brackets y, close brackets, and then in brackets 0 is 1. And then end curly brackets, and then just write what it's with respect to. So y of x in this scenario. Nice. Okay. So sequences in series. We can find the limit of convergent sequences in series using the limit and sum functions in Maple, if we know an expression for the nth term. So finding the limit of a sequence where the nth term is 1 over n plus 1, and then finding the sum of 1 on 2, continuing like 1 on 2 to the power of n. Use the sum function first and then the limit function. So, okay, these are different things. We'll first do the limit one. So the limit of 1 on n plus 1 while n goes to infinity, approaches infinity, is just 0, which makes sense. And then we can find the sum of 1 on 2 to the power of k, while k is between 0 and n. And then if we want to find the limit of that, just use the limit command, then percentage, because that's just what's above, and then n approaches infinity. Nice, which is just 2. Okay, so last one on further calculus is the Taylor series. So Taylor series can be easily found by Maple's Taylor function. So if we want to find the Taylor series of e to the power of x from 0 to 5, we can just do Taylor in brackets e to the power of x from x equals 0, 5. Nice. And then if we want to find the Taylor series of e to the power of x sine x from pi on 2 to 8, we use the polynomial to convert to a if we want it in a polynomial form, we need to use the convert command. So for an example, define it first. So S is the Taylor series of the exponential of negative x times sine x, where x is between pi on 2 and 8. Great. Okay, and then converting it to a polynomial. So that's just convert S from above and then polynom. So that's just the command for polynomial form. Nice. Okay, so I have a practice question for this one. Alright, yeah, just do this one here. So if we want to do this question, it says, suppose the Taylor series for e to the power of 4x on 1 minus x about 0 is a0 plus a1x plus a2x squared da 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 to a7x7. So first we'll define the, okay, call it, we haven't used J, Taylor. So that's x4 times x over 1 minus x. And then we want it between x is 0 and then also 8. So we get that x is 7th term. X to the power of 7th term once we convert to a polynomial. So now it wants it in a polynomial form, so we'll use the convert command. So convert S polynom. Oh, sorry, yeah, J. Thank you. Nice, so now we have the first term, so a of 0 will just be 1, and then a of 7 will be this term here. Alright. So, next section is further linear algebra. So I'll just start a new page here. Okay. So vector and matrix operations. So to multiply a vector by a scalar, we use the asterisk symbol. To add or subtract vectors or matrices, we use the plus or the negative symbol. And then remember, only vectors of matrices of the same size can be added or subtracted. And then to multiply vectors and matrices, use the dot. And then square matrices can also be raised to a power using the caret symbol, and the determinant and inverse can also be found. So if we do the example below, define V as 1, 2, 3, the vector 2, 3, and then W by 4, 5, 6. And then we can also define A by, let's just do V, W, and then also 7, 8, 9. There we go. Alright. So we can do the multiplication of the V and W vectors by V dot W. So make sure that we don't try to use the asterisk symbol when doing vector and matrix multiplication, because you will get an error, which I'll show you. So it just won't work. So make sure that we use the dot. And then to find the cross product and the dot product, we have to load the linear algebra package. So we'll write with, and then in brackets, linear algebra. So that's capital L, capital A. Yep, so you get all of these different commands. And then we can find the cross product. So if you forget what the commands are called, you can always just have a look and try to find them through. So find the cross product of, we'll list the vectors, so V and W, and then we can also find the dot product. And then same list. Nice. Okay. So matrix properties. So we can also use Maple to find our information about a matrix, e.g. its kernel and its rank. So we can find the dimension, the row dimension, column dimension, rank, basis, row space, column space, and null space. So we need to remember to load the linear algebra package before we use any of these commands. So if I have, go to the practice questions. Those ones are at the front. Okay. Okay, let's call this something different. Let's call it this. Okay. So if, oh wait, no, this wasn't the one. This one here. Alright, so I'm just going to type up this matrix here quickly. 41, 37, 39, 43. I can't copy and paste it because it's a photo, so it's okay. But if you get this question, then definitely copy and paste it, because you're much less likely to have errors. So 43, H, negative 36, 165, 115, 78. And last one, negative 78, 576, 252, 204. Okay, I'm just gonna quickly check that all looks good. Yep. Okay, great. So to find the nullity, we can use a few different ways to find it. So either we can find the rank. So there isn't a nullity command. So we either find the rank of A, and then there's the rank columns plus the nullity columns is the amount of columns in the vector. So in the matrices, sorry. So the nullity would be 2 because there's 5 columns. So if you don't want to count up the column, the amount of columns, you can use column dimension, which just tells you the amount of columns. So 5. So 5 minus 3 is 2. So that's the nullity. Or if we don't want to, if we want to use a different way, we can just find the reduced row echelon form of A. And then you can look at it and you can determine that it's 2. Okay. So that's part A. And then part B. So for matrix A, select all the statements below which are true. So below, it has all these different vectors, and it wants us to tell them if it's in the kernel. So either a longer way we can do this is like type up the vector and multiply it and then see if we get 0. But a shorter way is using the null space command. So null space A. And then if a vector is in the null space, then it's in the kernel. Yeah. So the null space gives you a basis for your kernel. So any vector that is a linear combination of the null space vectors is in the kernel. So we can see that 2, -1, -6, 0, and 1 is here, and it's also in the answers. So that's why it's an answer. And then, yeah, the kernel is a subspace of R5, which makes sense. And then these 2 vectors here aren't in it. So if we don't want to use the null space, we can just type them up. So we can define B as -2, 1, 6, 0, and 1. If we want, and then we can do A dot B, and then that's not going to give us 0. But if we change B to 2, -1, -6, 0, and 1, we'll get the 0 vector. So we can tell that it is in the kernel. And then, yeah, this 0 vector in the 5th dimension is always in the kernel because the kernel is a subspace, and the 0 vector is in the subspace. But this is, the one under isn't because it's 4D, so it wouldn't be. Okay, next one. Okay, let's do new, because I like using A. Okay, so just typing this up again. So 80, -47, -95, 22, -90, 83, -92, 98, -10, 36, -187, 120, 90, -83, 92, -98, 720, -664, 7, thank you, 736, and -784. Alright, finally. There we go. Alright, so to find the rank, we can just use the rank command. So rank A. Oh, I haven't loaded the linear algebra. Okay. Is it not gonna let me do it first? Wait, I can load it. Okay. That's why it's very important to load the linear algebra package. Good. So rank of A, just 2. Nice. And then part B, for the matrix A, select all the statements below which are true. So statements below is it's asking if a vector is in the image of A. So to find if a vector is in the image, then we want to find the column vectors. So if we use column column space, sorry. A. And then if like some linear combination of the column space gives the image, then we know that that vector is in the image. If some linear combination of the column space gives the vector, then we know that the vector is in the image. So yeah, in the column space we have, if we see this first vector, it's 1 at the top and then 0, and then the second one 0 and 1. So if we look at the possible vectors that could be in the image, we can try to write linear combinations to find them. So let's first copy this and let's call it A, and then we can copy the second one, and we can call this B. Nice. Okay, and then we can try to find a linear combination to find a vector. So if we see the first vector is -1 is the first, like the top value, so we can do -A, and then the second value is also -1, so then we'll try -B. And we don't get the vector. So we don't get -1, -1, 1, 0, 0. So that's not in the image. And then the next one, the first value is the top value is -800. So then it's -800. And then B is 711. So we'll do plus 711. So that's like timesing the vector, which we need to do. Nice. So we get the vector that's outputted is the same one as the one in the question. So it is in the image. Yeah. So if we want to do this one, that's just 800A. The 1, 2, 3, 4, 5, 6, 7th one. This one, but that is not the vector. So this vector isn't in the image. And then, yeah, the 0 vector is in the image because the image is a subspace. Alright, I just wanted to do one more question. Oh, this one? Yeah, this one. Okay, so let's get. So you only need Maple for question 2, so we'll just jump straight into that one. So to find a to the power of n, it's the matrix M multiplied by the matrix D multiplied by the inverse of n. So in Maple, M is defined as 4, 3, 4, 3, -4, -4, oh yeah, thank you. There we go. Okay, and then D is capital D doesn't work. I think it is a command for something, so just use lowercase d. D is -3, 0, 0, 6, and then we can use, sort of find the, what's it called? There is, it's like matrix inverse, I think it's called. Yeah, there we go. Matrix inverse of M. So to find the inverse. Or you can just do it to the power of -1, since it's a square matrix as well. So then, yep, and then to find d to the power of n, we can just insert the powers into here, because like by matrix multiplication, we can just do this a bit easier. And yep, and then can find m of d of, where d is capital D to the power of n, and then we can call this like n. Yep, and then that's the answer there. Okay, back to here. So to find eigenvalues and eigenvectors, we load the linear algebra package first, and then after we assign a matrix, we can find the eigenvalues by using the eigenvalues B command, and then eigenvectors is the eigenvectors B command. So if we're defining B, 0, 0, 1, 0, 1, 0, 0, 1, 0, 0. There we go, and then to find the eigenvalues, so it's just capital E, not B as well. So eigenvalues of B, is that, and then eigenvectors. Are those. Pass you on to Wesley. Thank you for this.
Okay. Alright, hello everyone. My name is Wesley, and I'll be going through the rest of the Maple workshop today. So we'll start with some 3D geometry, and then we'll move into some programming in Maple. Okay. So I know Jasmine already went through how to do dot product and cross product using the linear algebra package, but there's one more function here, the norm function. So yeah, you can use this for either vectors or matrices, and it takes 2 arguments. So let's look at an example of this. So what vectors do we have? Okay, let's just define a vector first. So it's u. The values 1, 2, 3. Okay, and now if we want to find the Euclidean length, so or the 2 norm of this vector, we can just pass in the vector and then the value 2, and that will give us 14. So yeah, that's just us squaring all the values in the vector and then taking the square root of the sum. Okay, cool. Yeah, you can also do the 1 norm, which of a vector isn't very interesting. It's just the sum of all the values in the vector. So that's 6, looks about right. And we can also take the infinity norm. So if we just, this is tricky. Okay. Okay. This is not giving me infinity for some reason. Okay, sorry, yeah, on my computer, just typing the escape button gives me infinity, so let's just try that again. Okay, nevertheless, if you know how to type infinity, you can just get the infinity norm by typing that. Okay, cool, that's enough of that. Let's move on to the Geom3D package, which is going to be quite useful. So first let's just import the package. And yeah, as you can see, we have all these different functions that we're going to be able to use. Not all of them will be very valuable for us, but the main thing we're going to use this module for is defining objects. So there's heaps of different objects you can define. A few examples are points, lines, planes, spheres, and other objects like triangles or line segments. So yeah, we'll go into each of those. First, let's define some points, which are going to be helpful when defining other things, other objects. And how you define a point is you just use the point command and then name the point. So I'm just going to call this point A, and then give it a value. Okay. Is A defined somewhere else? Okay. Let's try B then. Oh, you have to find B somewhere else as well. Shoot. Okay. Oh, we can just open a new file, eh? Okay. So I'll just import this again. Okay, great. Okay, now we're going to be able to find the point and make sure nothing else is defined in your file. So here we go. Great. Okay, now it looks like it's worked, and we can make sure it's worked by running the command detail. And this is going to be quite a useful command. It's going to make sure that whatever object you've defined has sort of worked properly, and different objects give you different sort of parameters out of the detail command. So if we look here, we've got the name of the object and the form. It's just point 3D because it's from the GM3D module, and then the coordinates that we've given it. Okay, cool, and that's the gist with defining points. Okay, now defining lines. So with the rest of these objects, there's quite a few different ways of doing it. One way is just to give it the name and then the coordinates of 2 points. So first let's define another point, B, and give it the value 1, 1, 1. Okay, and now we're going to be able to define a line, and we can call it whatever we want, but I'll just call it AB for simplicity. And then pass in the 2 points. Okay, good, that looks like it has worked, and we can make sure by running the detail command again and seeing, yep, so we've got the name of the object, the form, and the equation in parametric form, so that's very good. Okay, another way to define a line is to give it a point and then the direction that the line should go. So it will go through the point and in the direction that you give it. So let's try that. We'll call this line L1 and give it the point A and the direction 1, 1, 1. Okay. There we go. Now if we detail that, so this isn't going to be the same as the one before, even though it looks like we've kind of passed in 1, 1, 1 twice. So if we just run the C, yeah, so it's a different equation, right? And that's because it's not just a line passing through 2 points, it's a line passing through the point A and then in the direction 1, 1, 1. Okay, cool. Now let's try this next method, which is just using the parametric vector equation and then passing in the parametric variable as well. So let's try this. So we'll give the x value 1 plus t, y value 2 minus 2t, and the z value 2t. Passing in a parametric variable. So let's see here. Okay, this is very peculiar.
Yeah, the multiplications.
Oh, okay. Okay, yeah, sorry. Yeah, there we go. Okay, very nice, thank you, Matthew. Okay, and yeah, as you can see, we've got the name of the line L2 and the equation, which is like literally just the values we put in, 1 plus t, 2 minus 2t, and 2t. Okay, great. And that's the gist with defining lines. Let's move on to defining planes, which again, there's quite a few different ways of doing this. One is just to give 3 points that the plane goes through, and then Maple will just define the plane for you. So let's first make another point, C, and there we go. That looks like it's worked. And now we can use the plane command, give the plane a name. So I'm going to call it ABC because it passes through the points A, B, and C. Okay. And let's just see what that has done by running detail. Okay, yep, and again we've got the name, we've got the equation of the plane, so yeah, all very helpful. Okay, another way to define a plane is to give a point C and then the direction of the normal. So let's try that. Again, running the plane command, we'll call this one just P for plane, and then give it the point C, and give it the direction of the normal 1, 1, 1. Okay. Okay. Yep, that looks like it's worked. And again, yeah, we've got the equation of the plane. Yeah, all very helpful. You can also use just like the equation. If you just want to see the equation, you can just run the function equation. But yeah. Enter the name of the x-axis. Sorry, yeah, you have to run the thing you want the equation of, and then also the variable like with respect to. So let's just do that. Enter name of the x-axis. Why not just x-axis? Oh, okay. Okay, it wants the name of the axis as well. Okay, yeah. Sorry. Here we go. If we give it the name of the axis just in here, then it will work nicely. Yeah, okay. So I've just rerun it, and yeah, there we go. So if you just want the equation, you don't want to oh yeah, because our plane isn't defined in terms of t, so that's why t didn't work. Yeah, you just put in the name of the axes, and it will give you the equation of whatever you put in there, whether it be a plane or a line, or a sphere, as we'll move on to later. Okay. Another way is just to give the actual equation of the plane, so that's also pretty useful. So let's see, we'll call this one P2, and we'll give the equation of the plane. And the name of the axes. Cool. Enter name of the y-axis, so it seems like it doesn't like that. P2, x, y, 6, 7. Okay. Interesting. So it doesn't like exactly what I've done here for some reason. Let's just see. So I've given the, unless I'm missing like a multiplication or a bracket. I'm not entirely sure what I'm missing here. So one useful thing you can do is do question mark and then the thing you're a little bit confused with, and it will bring up some information about that function. So let's try do this. So yeah, what I'm trying to do here is give plane, equation, and then n. So we can look at the parameters. N is list of 3 names representing the name of the axes. So that's kind of what I was trying to do before. And the equation, okay. Let's get rid of this. Okay, let's just try it again. Maybe I was just missing something. Okay. 7 and x, y, z. Yeah, I don't really know exactly why it's, I've never seen this before, to be honest. Let's just, I just detail. Okay, so it seems like it knows what the object is, but it still wants a name of a y-axis, and when I give it to it, it's not even accepting it. So, okay, let's just ignore this for now, and let's get rid of this so that it doesn't keep asking me for the name of the y-axis. Although it does seem to have worked, and it worked on my computer. But, okay, nevertheless, let's move on. Okay, defining spheres. So yeah, just like with lines and planes, there's quite a few ways to define spheres. So one way is just to give 4 points that you want the sphere to pass through, and Maple just automatically will make a sphere that passes through those 4 points. So okay, I'll make one more point, and yeah, like Jazz mentioned, D's used for something in Maple, so I'm just going to use X, and let's just try 5, 7, 9. Okay, and it's still asking for the name of the y-axis, which is pretty insane.
Maybe in this.
Yeah, okay. Unfortunately, this means that I'm going to have to quickly I'm going to have to quickly redefine some points here. So let's just B and so yeah, for a sphere you need 4 points, so it's like it's kind of necessary to have all these points here. Okay, yeah, 4 random points. Oh yeah, see, so it doesn't like when I use D, so let's just use X. Great, okay. Okay, now defining a sphere using the sphere command. So let's give the sphere a name. So yeah, a common mistake is to forget to give things a name. So let's just give it a name and then give it the 4 points. A, B, X. And as long as none of them are like collinear, this should work. And you can also give an optional argument for the center name if you want to use a center name for something. Otherwise, it's not essential. So let's just chuck that there. So detail. Okay, great. So yeah, it gives the radius, the surface area, the volume, and the equation. So yeah, that's pretty useful, pretty nice. Okay, another way you can define a sphere is just with 2 points, and these will be the two endpoints of a diameter on the sphere. So if you just pass in 2 points, Maple knows just to use that formula. So let's try that. Sphere, and we'll call this one S1, and we'll give it the points AC. Okay. So if we detail S1, yep, great. So we've got, yeah, the radius, surface area, and there's also like a distance command, so we can check that this radius is right by taking the distance between A and C, and it's √2, so yeah, that should be the diameter, so the radius, as it shows here, is √2/2. Okay, great. Now another way to define a sphere is to give a point, and then instead of another point, just a radius. So let's try this. So a point, and then a radius. Cool. And we can show that this has worked because the radius should be 4. Okay, yeah. And it's centered on 1, 1, 1. Okay, great. So that's how you define a sphere in Maple. Nice. Okay, there's a couple other objects that we're going to be able to define in Maple. So let's first look at a segment. So how you do a segment is just type in segment, and then give it a name. And then, so a segment is just like a line, but not like with infinite length, right? So let's make a segment just between A and C. Segment, okay, I didn't really like that. So again, segment. Ooh, okay, yeah, there we go. Spelling a bit off. Okay, so now if I want to detail that, I'm going to be able to see, yep, we've got a segment defined with the name seg, and the 2 ends are there. Okay. Now, if you want a directed segment, which just means that the order of the start and end point matters, then you can just do D segment, and I'm going to call it D seg A and C. Cool, and then detail for D seg, and it's going to be very similar to the one above, but now it just says, instead of the 2 ends of the segment, it says the initial and end points of the directed segment. Okay, great. So that's how you define those two things. You can also define a triangle. So let's give this a go. Triangle, and just give the 3 points of the vertices. Cool. And there we go. So we've got, yeah, a triangle defined with 3 vertices. Very nice, very nice. Okay. Oh, here we go. So, yeah, like I've been using throughout this, we've been using detail to give us some information about the object that we've defined. You can also use equation, as I mentioned before, so let's just try it again. So I don't think I've got line defined here, so I'm just going to quickly define this line between A and B. Okay, great, and now I can get the equation of this line. And if I pass in the variable I want it in terms of, there we go. So that's the equation of the line AB that I just made. And you can also get the equation of like any of the spheres you've defined. Again, passing in the name of the axes. And there we go. So we've got the equation of the first sphere that we defined earlier. Okay, yeah. So we need to give Maple information on the names of the axes, or they'll just like be asking you all the time for it apparently. So it's good. Okay. Now intersections. So if you ever want to find where two things intersect, for example, a line and a plane, which is what we'll do now. So again, I'll just quickly define a plane. There we go. And if I want the intersection between, okay, well, I'm going to call the intersection point G, and I want the intersection of the line AB and the plane ABC. Okay, line lies in plane ABC. Okay, let's just change this to ABX. Yeah, that's a good point. Line AB lines in AB. Oh, of course it does. Such a good point. Okay. Okay, there we go. Now if we detail that, so intersection should just return a point, right? Because it's just like the point where they intersect. And there we go, yeah. So again, yeah, that sort of makes sense that that's the intersection point, to be honest. Okay, yeah, that's kind of it with intersections. Now let's look at plotting. So yeah, we can plot any of these objects that we've made. Let's do an example with the sphere. We made the first sphere and the plane, what is it now, ACX. Okay. So let's do the sphere and the plane. Very nice, very nice. And yep, you can just click and drag around to see what's going on. Very, very cool. Okay. It might be a little bit confusing having these as like the same sort of color, so the sphere and the plane. So you can change that in the command as follows. So S, so for the sphere, and then we want the color of the sphere to be pink. Yep, that looks good. And then we want the plane, so that's what, ACX. And we want the color to be blue. And as long as I have got the brackets right, there we go. So yeah, you guys can see that this is very nice now. Now you can see the difference between the sphere and the plane pretty easily. And okay, cool. So that's that. Alright, so there's a few like extra things that we can look at. So there's find angle. So if you want to find the angle between a line and a plane, literally just type in find angle, and then yeah, you can do it either order, but let's just do it the plane first. And if we've got both of these defined, then yep, we've got, that would be the angle between them, which is, yep, very nice. And then yeah, like I've said before, you can use the distance command to find the distance between 2 points, or yeah, so that's pretty much that, to be honest. And I think now we can move on to some programming in Maple. Okay, so yeah, if you've ever done like some C code, maybe you're doing comp 1511 or Python, like it's kind of like the same ideas. The only thing that's different is the syntax. So yeah, like it says here, we can translate ideas from programming into Maple. For example, loops, conditional statements, and procedures, which I'll cover all that today. And yeah, this is like very helpful. You'll kind of see how it can simplify a longer problem into smaller problems. So let's just have a look here. So in Maple, we have this thing called procedures, which is just a series of actions. We can think of functions as procedures because they take in a number and then perform a series of actions like a procedure does on that number. And so this gives us two ways to define functions. So I'm going to quickly define the same function in two different ways. So let's do this first way. X, and you should all be pretty familiar with this one. And so let's do f of 3, 6. Great, that's quite as expected. And now let's make another function which will just be the same thing, except it's going to be a procedure that takes in an argument x, so proc x. And then what do I do with x? Multiply it by 2, and then you always have to say end proc. So yeah, this is like the syntax side of things. So okay, yep. Here we go. And now if we go g at 3, hopefully we get 6. That's great. Okay, now you've done your first ever procedure in Maple. It's a pretty simple one because, like, as you can see, you know, it's like, why wouldn't you just use a function for this? And you probably should just use a function for this. But procedures are going to be able to use like conditionals and booleans in a way that functions, it's not so obvious how to use them for functions. Okay. Yeah, here we go. The advantage of defining functions as procedures is that it allows us to perform multiple actions on the number we input in. So yeah, let's have a look here. So if we want to double a number, square it, and then add 1, we can do that all in the same function. So let's just do that. So yeah, this is like the multiple actions sort of thing. So instead of using like a whole bunch of brackets, which is what you'd usually do, you can just make a procedure that takes an input x and then doubles it. And then so the percentage operator here just means take the answer from the previous evaluation. So just take that answer. So, you know, if it's 3, for example, then 2 times 3 is 6. So take 6 and then square it. So we can just do that normally. And then add 1 to whatever that was. And as always, we have to end the procedure. Okay. And so I think I've just redefined f's here, so I think that's fine. 37, that's great. Okay, I know on the slide it says 36, but as far as I'm aware, it should be 37, because 3 times 2 is 6, squared, 36, add 1, it should be 37. So yeah, that's working as expected. Okay. Now we're going to look at some booleans. So yeah, Maple can evaluate the truth of mathematical statements using the function eval_b. So let's give x a value here and then look at an example. So eval_b is either going to return true or false based on what you put in it. So yeah, it's like pretty obvious that this is true, right? Because 6 is bigger than 3, and we know that. But when you're evaluating like more complex things that are not so obvious, it can be useful to use this eval_b function like this, even though this is also, you could argue, like pretty obvious that this would be, you know, less than 0, so that'll be false. But yeah, eval_b is like pretty useful when something's so complex that you wouldn't want to have to like kind of work it out yourself. And yeah, you just kind of want to see if something's true or false. Okay, I think that's enough for booleans. Okay, let's move on to conditional statements. So yeah, like with other programming languages, we have like an if command in Maple, again built in, so we don't have to import anything. And this is sort of the syntax behind it. It goes like if, condition, then, you know, do something, and then end if. So you know how we have to end proc, also end if, when we have a if statement. I think this stuff sort of makes more sense with an example, so let's go through one here. Okay, let's write a program that finds the circumference of a circle with radius r and rejects negative radii. Okay, So we'll call our procedure circumference. And there we go. It's a procedure that takes in a radius r, and then you can shift enter to stay in the same, to not run the command sort of. So that's good. And then we're going to have if r is less than 0. So this is the if condition then. Okay. We can like raise an error using the error keyword. And this is like the message that will be given if you try to use a negative radius. Okay, and it will return out early as well. Okay, now we always need to remember to end if, so that's a good point there. And so otherwise, so if we don't have an error, then we know the radius is bigger than or equal to 0. We can return the evaluation of 2 times, okay, I might run into trouble here again. Let's just see. Okay. With pi. Okay, jeez. Alright, here we go. Favorites, surely. No favorites. Oh shoot. Okay, sorry. I was waiting for it to load. Yeah, there we go. We have pi there. Okay, so yeah, this is another way to do pi if the escape thing doesn't work. It's just pi, and it seems like it's just written pi, but hopefully it knows that it's actually pi since I just put it there from there. Okay, great. So yeah, if the radius is positive, it should just return 2 times pi times up. And as always, we need to end proc. Okay. Now let's see if this works. So first let's try a negative number. Okay, so it looks like we've just got a normal maple error, but we've also got this here, negative radius, which is what we typed in. So that's pretty cool, pretty robust for malicious input. And we can also look at circumference of 2. Oh wow, that's good. It's got the same number that is in the slide, so that's very good. Seems like it's working. Okay, and yeah, that's like just a more complex procedure with an if condition in it. And cool. Okay, now let's move on to loops. So yeah, like other coding languages, we can do loops, and we've got a for loop here, which has the syntax. So for I, from starting point by how much we want to increase it by to endpoint, do something, and then end do. So again, like I think that just looks really complicated just reading it out like that. So looking at an example will help it make a lot more sense. So let's give this a go. So total. So we'll set total to 0, and then again, yeah, shift enter to stay in the same command. And then we're going to go for I, so like I will be a number from 2 by 1. I'm pretty sure if you don't use by 1, it automatically does by 1, but just for completeness sake, we'll do by 1. And then, so for each number from 2 to 12, basically, from each whole number from 2 to 12, do total, so assign total to be total plus whatever the number is squared. Cool, and then end do. And so it should just, yeah, there we go. So it prints out all the intermediate answers as well as the final answer. And again, this isn't even a proc, so it's like we don't have to input anything, it just Maple automatically calculates it. And so yeah, you can do like way more complex stuff than this. You could do like integrals in your for loop or whatever. It's just like the initial syntax is kind of the hard thing to get over, like the for I from 2 by 1 to 12. You might have to look at that a few times before it sort of sticks. Okay, cool. So now let's look at a practice problem. So this is a real life example. Suppose we have a set of prime numbers. How would we evaluate the sum of these primes squared? And there's a great point here. You can't use sigma notation because there isn't a consistent pattern between the primes. So the solution is that we can use loops. So let's have a look. Let's define primes and assign it the first few prime numbers. Okay. And then assign total initially to 0. And now let's make a for loop. So yeah, like you don't have to use I. In this case we use P because we know like each number is gonna be a prime number. So it kind of makes sense to use P. So for P and prime, so that's saying like for each P and sort of like it's like a primes array kind of, like if you were using Python or a list. Okay, so for each P and primes do total is total plus the prime r squared. Very nice, very nice. And then we always have to end do. Here we go. Nice, and it seems like we probably have to do that. There we go. Yeah, so yeah, usually when you use a normal colon, it doesn't show you the output straight away, but if you use a semicolon, it will. So there we go. That's kind of the answer that we were probably hoping for. So you can always check that on your calculators, but I think that's pretty robust. Maple's pretty well renowned for calculating square numbers of primes. So okay, and here we go. So we've got our last sort of example here, where we can combine all these ideas together to create a program. Okay, so yeah, as an exercise, let's create a function that takes as input an integer n and outputs -1 if the integer is negative or 0. But if it's positive, the procedure should output the sum of the integers 1 to n. So okay, let's give this a go. So I'm going to call this summation because again, sum is like a keyword in Maple. And it's going to be a procedure that takes in a value n. And so okay, so the first thing we want to do, the first thing it says is like, it outputs -1 if the integer is negative or 0. So let's just do that first. So if n is negative or equal to 0, then literally just return -1. That's good. And then as always, end if. Maybe it's a bit more clear what's going on if I indent a bit. Okay. And then otherwise, we want to add all the numbers up from 1 to n and just return that. So, okay, let's go start with total 0. And then for I from 1, and I'll just do by 1 to n. And for each value there, we want to add that to the total. Cool. And then yeah, end do as always. And I think this isn't going to fully work. We're going to have to do end proc as well. End proc. There we go. Okay, that looks decent. Let's see. So yeah, it says that these variables are implicitly declared local, which seems scary, but it just means that Maple's treating them as local variables, which is fine. Summation, oh, if I've spelt it right, summation of, let's just see, -5, right? -1, good. And now let's try summation of a positive number. 15, great. Okay, yeah, so it seems like that I think that is the correct answer. So I guess one more thing we can do to this procedure is instead of making a for loop here, you could simplify this just by returning like the formula for the sum of the first n numbers. So I think, there we go. if we just enter. And we enter again, yeah, we get the same answers. So yeah, there's a simple way of doing it, but I mean, that doesn't use a for loop, so it's not as instructive. Nevertheless, I think we're at the end of our slides, so that's the end of the Maple workshop today. Thank you so much for listening. I hope it was very helpful, and good luck for your assignments and tests, and yeah, the rest of your uni career really. So thanks so much. Yeah, see ya.
So